Students, in your last class, we were discussing about the reflection of waves, and we have also seen what are the laws of reflection, isn't it? As I told you all that the two laws of reflection that are seen, that is only the path of ray, that is the direction of this wave motion is described only in those two laws. Okay. So these two laws do not give any idea regarding the change in the properties of the wave due to the reflection. That means when the wave is moving from this first medium and it's hitting to the interface, so obviously the path of their ray is being mentioned. That means in which directions, how will it move, all these things are given in those two laws. But we don't get any clear idea that whether there is, if any, change in the properties of the wave due to this reflection, isn't it? So in today's class we will learn more about it regarding the rules of the reflected wave. That means if there are any chances of changing in the properties of the wave due to this motion reflection, that we will see. Rule number 1, I think we have done in the last class. Now we will start from rule number 2. Okay. What is the rule number 2? That if the incident wave, that means this, if the incident wave or ray, just imagine, if it falls on a hard surface, that means if this POQ, imagine that this is your interface or the surface and it is very hard. Alright, then what will happen? The vibration of the particle of the medium at the point of incidence is nil. That means when this wave is hitting on this hard surface, then the vibration of the particles is expected. But what is happening in original? That vibration of the particle of the medium at the point of incidence is nil. That means you cannot see at all the vibration of the particles. Okay. And this particular point is called as the node. That means for that case, this particular point is known as the node. And the interface is called as the closed reflector. That means in this particular rule, this your usual interface will be termed as your closed reflector. And the point where the vibration of the particle is basically nil, I am writing here rule 2. Vibration, I am writing in short, students, the vibration as vib dot. Vibration is nil at point O, or you can term it is by any alphabet. Vibration is nil at the point which is called as the node. Okay. And the interface, that means this particular interface will be termed as your closed reflector. Alright. So basically, so this is your rule number 2. Okay. So now see, let us move on to the rule number 3. If a wave advances through a medium and is incident at an interface of comparatively soft medium, that means this particular thing is just the reverse of rule number 2. In rule number 2, we have seen the case of this hard surface, but in rule number 3, we will see that what happens when the wave will advance through a medium at an interface of soft medium, comparatively soft medium, if you just compare it with the hard interface that you have seen in rule number 2. Okay, what will happen right now? The vibration of the particles of the medium at the point of incidence is maximum. That means when a wave is traveling from this part, from this medium 1, and it is hitting to the interface, softer medium, the vibration will be maximum. Clear? So here also it is just the reverse of the rule number 2. Okay. And that particular point is known as the antinode, where that particular point is known as the node in case of the hard interface. Hard interface. Okay. Rule number 3, I'm writing here. Vibration is maximum at antinode. Alright. And the interface is called as the open reflector. Just in the case of hard, it was a closed reflector, and in the case of softer interface, it is called as the open reflector. Okay, this is for softer interface. Alright. Okay, so our rule number 3 is also done. Now let us move to the 4th rule. If any wave is reflected from a closed reflector, the phase of the wave is changed and becomes opposite. Okay, that means think about the rule number 3. Okay, that if a wave is reflected, that means this part, that means after heating the surface, it is obviously it will get reflected. So at this time, the phase of the wave is changed and becomes opposite. That means the crest of the transverse wave is reflected as a trough of the wave. Okay, so I hope students, we have discussed many times that how the crest and troughs are being seen in the case of the transverse wave. So here also you can able to see in the case of the closed reflector. Okay. So this particular thing, that when the wave will reflected from a closed reflector, as I told you all, that the phase of the wave is changed and it becomes opposite. So crest and trough, that means the crest of a transverse wave is reflected as a trough of the transverse wave only. So if you think in the case of the longitudinal wave, so what will happen? The compression of a longitudinal wave will be reflected as a rarefaction of the wave. That means the phases are changing, isn't it? And it is becoming opposite. The crests are becoming trough and the compression are becoming the rarefaction, isn't it? Okay, now let us move to rule number 5, the last one. If any wave is reflected from an open reflector,